Welcome to my updated body tracking tutorial using RealityKit and ARKit. In this tutorial, you'll learn how to visualize the skeleton joints and bones for an AR body anchor. If you'd like to fast track to a solution, join the Pro membership on our Patreon. With the Pro membership, you'll get access to the final source code used in this tutorial. Now let's get started. Make sure you have the latest Xcode. I'm using version 13.4.1. We're going to create a new project and select the app starter template. We're going to use SwiftUI as the interface and Swift as the language. Don't select test or core data. In this case, I'm going to just find a location to store my project. Just to give us a bit more space, I'm going to disable the canvas. We don't need a preview for SwiftUI just because we're going to use augmented reality in this case. Okay, next, what we're going to do is we're going to go to our project settings and go to info. We're going to essentially ask permission to access the camera. And so we have to add a privacy statement in our info plist. This will be the message that the user will see when we're requesting access to their camera. So in this case, I'm going to add something like this app needs access to the camera to enable augmented reality features. Next, we're going to create a SwiftUI wrapper for our ARView. An ARView is a native UIKit based view, and so we want to be able to wrap that in a SwiftUI view. So we're going to create an ARView container. In this case, we'll create a new file, right, and name this ARView container. We're going to import SwiftUI, ARKit, and RealityKit. Next, we'll create a struct called ARView container, which will adopt the UI view representative protocol. This allows us to wrap a UIKit-based view as a SwiftUI view. Now we're going to see an error, and so we're going to use Xcode to help us fill out, to essentially conform to this protocol. So we'll have a UI view type, which is in this case we're going to do an ARView, and then we're going to again use Xcode to essentially create stubs for the required methods to adopt this protocol. I'm going to move the UI view type up top, and as you can see, we have a make UI view method and an update UI view method. These are required to conform to UI view representable. In the make UI view method, I'm going to create an ARView, and we're going to set the frame to 0.0 because SwiftUI will essentially infer the size. The camera mode is AR, and we want to automatically configure our ARView. This is the simplest way to set up an ARView. And then what we're going to do next is we're going to return our ARView as part of this make UI view method. And for the update view, we're going to leave that empty. Now in our content view, we're going to remove the boilerplate hello world code and instead create an instance of our ARView container, and also say that we want to ignore the safe area edges for all sides. This modifier will essentially fill our display on iPhones that have a notch. Now, just to make sure our basic ARView is working, we're going to run the project, and you can see here that our ARView, we have a basic camera setup, but our ARView is working. That's great. Next, we'll need to create several objects to be able to visualize a body skeleton. And so there's several objects that we're going to create to do so. Now, we're going to start with a skeleton joint. We're going to create a struct, and we're going to name it SkeletonJoint. And this struct will have two properties. It'll have a constant name, which is a string, and it'll have a position, which is a variable, which has a type of SIMD3 of float. So it's essentially a vector in 3D space where each of those individual components or elements is a float. Next, we're going to work on our SkeletonBone object. Now, this will essentially connect two joints in our skeleton. And so we're also going to import RealityKit in this instance because we'll be using a method that is defined in this framework. We'll create a struct called SkeletonBone, and we'll have several properties. The first one is a variable called FromJoint, which is a skeleton joint. The next one is ToJoint, which is also a skeleton joint. And then we're going to have two computer properties. The first one is called CenterPosition, and this is a computed property of type SIMD3 float. And essentially what we want to do is we want to calculate the midpoint between the from joint and the to joint. So we're going to create a vector, and we're going to use the position.x in this case for both the from joint and the to joint, and divide it by 2. This gives us essentially the midpoint for the x direction or x-axis. And we're going to repeat this for both the y-axis and also the z or z-axis. So as you can see here, we're just writing out this equation. Make sure to divide by 2 so that we get the midpoint. And this is essentially a 3D vector of floats. Next, we'll create a computer property called length, which is a float, and we'll use a RealityKit method called simd_distance, and we're going to give the from joint position and the to joint position. This essentially calculates the Euclidean distance between those two joints. It's essentially the straight line distance in 3D space between those two joints. Next, we're going to create a new file called bones, which will contain an enumeration of all the bones that we actually want to visualize for our skeleton. We're not going to visualize all of them, so I'm just going to define an enum for that. As you can see, we're going to also adopt the case iterable protocol so that we can get a collection of all the bones defined in our enum. Now, in the interest of time, I'm going to define 3 of these cases up front, and then I'm going to copy paste the remainder of all the other cases. I strongly encourage you that you type it out. It is easy to make mistakes, so make sure to really take your time. Now, for those of you that don't want to just waste time typing, I will have the source code available for pro members on Patreon. So if you want to speed up and just don't want to type all of it out, you're welcome to join the pro membership. Now, for everyone else, feel free to just pause the video and make sure to copy everything as best as possible. Otherwise, if you make any mistakes, it'll likely not work. So to make things a little bit easier, here you can see a list of all the joints that a skeleton contains. And in this tutorial, we're actually not going to visualize all the bones. So we're going to only do select joints and select bones. Now, what we're going to do next is we're going to create a few properties for our enum. So we're going to have joint from name, which is a string. And we're going to use a switch statement to essentially return the string for the relevant case. For this property, we essentially want to return the name of the originating joint for a bone, so the from joint. And so we're going to say for the left shoulder to left arm, the originating joint is the left _ shoulder _1 _ joint. For the left arm to left forearm, it's essentially left _arm _ joint. And for the left forearm to left hand, it is essentially left _forearm _ joint. By now, you should see kind of a pattern. We're doing the initial joint in the connection. We're also going to create another property called joint to name, which is essentially the destination joint for a bone, which is also a string. And again, we're going to use a switch statement. And we're going to have Xcode kind of like fill out our switch statement just to make it a little bit easier on us. And again, we're going to fill this out. This is now going to be left _arm _ joint because it's the destination joint we're working with. And we're going to do left _forearm _ joint. And then finally, we'll do left _hand _ joint. Again, all these names that are in all these joint names will be in the description of this video. Of course, if you have pro membership on Patreon, you can just copy paste it. And then finally, we're going to do a property called name, which is a string. And we're going to use string interpolation to essentially create a compound name for our bone. So it's going to be essentially the from joint name. And the second part will be the joint to name, and we'll have a dash in between. Next, I'll copy paste the remaining bones that I want to map in my skeleton. Again, these are not all the bones in a skeleton, but these are the major ones. As you can see, we're gonna map the left arm, the right arm, the spine to the shoulder, the neck to the spine, and the left and right legs. I'm also gonna essentially copy paste all the from names for each joint or for each bone, I mean. Again, pause the video so you can copy all of this. And it is very crucial that you copy the names exactly, because otherwise the joints will not be found when you're trying to visualize them. And we're going to do the same for the joint to name. Again, pause the video and feel free to copy all these names. Okay, so now we're done with our bones enum. And this was, I think, the most tedious part of the tutorial. After this, it's a lot more fun, and we should be making great progress with our code. So next, what we're going to do is we're going to create a new file, and we're going to call this BodySkeleton. This will be the class or the entity that will contain all of our visualized entities. We're going to import RealityKit, and we're also going to import ARKit. Next, we'll create a class called BodySkeleton, which will be a subclass of entity. Entity is a RealityKit-based class. Next, we'll add a required initializer method that takes in a AR body anchor. For now, we'll just call the initializer of the superclass in this method. Now, at this point, you should get an error with Xcode saying, hey, we haven't implemented a required initializer. So we'll just use Xcode to fix that. And we want to leave it as is. We essentially want an error to be presented to the developer whenever this initializer method is used, because we don't want this method to be used in the code. Now, next, we'll create two properties. We'll create a joins variable, which will be a dictionary mapping a string key to an entity value. We'll initialize this to an empty dictionary. We'll also create a bones variable, which will again be a dictionary mapping a string key to an entity value. We'll again initialize this dictionary as an empty dictionary as well. These two properties will keep track of the joint and bone entities in our scene so that we can update their properties anytime an updated body anchor is provided to us by ARKit. Next, we'll create helper methods to construct our joint and body entities. First, we'll create a method to create a joint entity, which takes in a radius and color. The method will return an entity. First, we'll create a mesh using the generateSphere type method from the mesh resource class. Second, we'll create a simple material to apply to our joint entity. And finally, we'll create a model entity using our mesh and material. We'll return this entity at the end of our method. To summarize, this method creates a sphere entity for every single joint in our skeleton. Next, we'll create a method to construct a skeleton bone, given a bone and body anchor. This method returns an optional skeleton bone because the joints that make up a bone may not exist. Of course, we're going to do our due diligence to make sure that every single joint we provide maps to an actual joint in our skeleton. First, we'll use a guard let statement to safely unwrap the entity transform of our from and to joints. If either of these joints don't exist or they don't have a transform, this method will return nil. Second, since all joints in our body skeleton are relative to the hip joint, also referred to as the root joint, we want to determine our root position in world coordinates. For the from joint, we'll determine the offset from the root position to then determine the entity position in world coordinates. Just to emphasize, the transform that we obtain for the from joint is relative to the root joint, and so we essentially want to calculate the offset vector to then add it to the root position so we can get the entity position in world coordinates, so relative to the world origin, not to the root joint. We'll perform the same two operations for our to joint. Once we have the position of the from and to joints, we'll create skeleton joints for each. We'll use the two skeleton joints to create and return a skeleton bone. I'd like to emphasize that a skeleton bone is not yet an entity that can be visualized. It is simply an object that contains the parameters needed to visualize a bone entity. Now that we have a method to create a skeleton bone, we can create the final helper method to create a bone entity. This method will take in a skeleton bone, a diameter, and a color. For the diameter, we'll add a default value of 0.04 meters and a color of white. This method will return an entity. Similar to our createJoint method, we'll create a mesh, material, and model entity. However, in this case, we'll use the generateBoxType method to create a cylinder representing a bone. The cylinder will use the diameter parameter and the skeleton bone length as its size parameters. We'll also assign a corner radius to make the box appear as a cylinder. And then finally, we'll return the entity. There are two things left to do in our BodySkeleton class. One, we need to add code to create joint and bone entities and to add them to our skeleton entity. And two, we need to create a method that will update the parameters of each joint and bone anytime ARKit updates our body anchor. First, we'll use a for loop to iterate over all the joint names as defined by our AR skeleton. Now, for each joint name, we'll create a joint radius variable and assign it a default float value of 0.05 meters. We'll also create a joint color variable and assign it a default value of green. There will only be yellow and green joints. Green joints are actively tracked by ARKit. Yellow joints are not tracked. They just follow the motion of the closest green parent. We'll use a switch statement to assign the appropriate joint radius and joint color for each joint name. Now, I'm going to again copy paste this because this is very tedious to type in and it will take too much time for the video. But make sure to pause the video, or if you're a pro member, copy paste the code and make sure that every single string that you type in here is correct. Next, we'll create a joint entity using our helper method. We'll add this joint entity as a value in our joints dictionary. And then finally, we'll add the joint entity as a child of our body skeleton. Next, we'll use another for loop to iterate over all the bones. For each bone, we'll use a guard let statement to safely unwrap a skeleton bone. Keep in mind that our create skeleton bone method returns an optional skeleton bone. If the method returns nil, we'll continue on to the next bone in our collection. Next, we'll create a bone entity using our helper method. We'll add this bone entity to our bones dictionary, and we'll also add it as a child of body skeleton. Note that we currently only have a method to create our joints and bones, but we're not yet updating them with new ARKit data. So we'll create an update method that creates a body anchor as a parameter. We'll again determine the root position in world coordinates. This is needed because every single joint is relative to the root position in the skeleton, which is essentially in this case the hip joint. Next, we'll iterate over each joint name and update the position and orientation of each joint. We'll use an if-let statement to obtain the joint entity from our joints dictionary. The reason we're using an if-let statement is because if we make a mistake, the joint entity may not exist in a dictionary, and so we're safely unwrapping it using an if-let statement. We'll also safely unwrap the joint entity transform using our if statement. Again, if we make a mistake, the transform may not exist for a specified joint. Inside our if statement, we'll determine the offset from the root and update the joint position. We'll also update the joint entity orientation. But because we're using a sphere to visualize our joint, we won't notice changes in orientation. Next, we'll use a for loop to iterate over our bones collection. We'll use a guard let statement to obtain our bone entity and skeleton bone objects for each bone. If for some reason the bone entity or the skeleton bone are nil, we'll continue to our next bone in the collection. Now that we have an entity and a skeleton bone, we'll update the position of the entity. We'll update the position of the entity using the center position of the skeleton bone. Finally, and this is very important, we'll use the lookAt method to automatically orient our cylinder in the appropriate direction. What we're essentially going to do is we're going to go from the mid position of the skeleton bone to the two joint position and essentially orient the cylinder along that direction. This is very, very important. Now, this completes our update method, which updates the position and the orientation of our joints and bones. Next, we'll navigate to our ARView container file. We'll create two global properties in this file. We'll create a BodySkeleton variable, which is an optional body skeleton. And we'll also create a BodySkeleton anchor constant, which we'll initialize as an anchor entity. Next, we'll create an extension to our ARView class and adopt the AR Session Delegate protocol. In our ARView extension, there are two things we need to do. First, we want to create a method to set up our ARView for body tracking. In this method, we'll create an AR body tracking configuration and run the configuration for our session. We'll also set the instance of our ARView as the delegate for our session. Second, we'll implement the ARSession.didUpdateAnchors delegate method. In this method, we want to obtain a body anchor from the collection of anchors in our scene. If a body anchor exists, we'll check if a body skeleton exists. If a body skeleton exists, we'll update it, meaning we'll update the joint and bone position and orientations. If it doesn't exist, we'll create a body skeleton and add it as a child to body skeleton anchor. To recap, we'll use the didUpdateDelegate delegate method to update our body skeleton every time ARKit has new data. In our ARView container struct, we'll update our makeUIView method to call the setup for body tracking instance method on our ARView. We'll also add the body skeleton anchor to our scene. We are now ready to run our app. As you can see, as I move my body, the skeleton is being tracked, and you can see that the joints are green and yellow, and the bones are this silver looking material. This was really fun to create. And that's it for this video. I hope you enjoyed it. If you did, give this video a like. It really helps out the channel. Subscribe if you haven't already, and I'll see you next time. Bye.